Hey everyone, welcome back to Mind Maths with Amina. Today I'm going to be solving sample examination questions given in this Statistic 1 study guide given by University of London with lead college being London School of Economics. This is chapter 2 and the first question is to classify each of the following variables as either measurable, as in continuous, or categorical. If a variable is categorical, further classify it as nominal or ordinal. Just as a revision, let's just define this. You all already actually know that continuous variables are all variables that you can measure in any kind of unit, right? So examples could be, you can measure time, right? You can measure a person's height, you can measure somebody's IQ, you could measure GDP of a country, you could measure temperature. So when the unit of measurement is given, you can easily measure this variable. So this is a continuous variable. When it comes to categorical variables, these cannot be measured, but they are represented as groups or categories. And these are actually not numerical measurements. So they are not numerical measurements. Okay. And therefore, we categorical variables are divided into two categories. We have either nominal categorical variables or ordinal. So what's the difference between nominal and ordinal? Nominal variables are, okay, let me just fix this first. Okay, nominal variables have no natural ranking or order. So there's no ranking and there is no order. A good example that I give my students always is gender. So for instance, if you're handling a data set where there are two options given for a gender, male, female, you could either assign male to a 0 and female to a 1, or actually a male to a 1 and 0 to a female. So the number itself has no ranking, no order. Okay, so just remember there's no hierarchy when it comes to nominal variables. However, when we're talking about ordinal variables, there is a ranking. However, there's like the difference between these categories is not measurable. So an example that I can give is satisfaction level, because it also relates to our question above. The satisfaction level, suppose with a restaurant services. Okay, so you go to a restaurant and they ask you if you're very satisfied or very dissatisfied. So suppose you're filling out a form and it gives you these options, and they say 1 stands for very satisfied and 5 stands for very dissatisfied. So 3 is basically indifferent. They could also have actually used the numbers like this as well. It wouldn't have mattered. It's just a number is being assigned to a category, and also, however, there is a feeling attached to it. So for instance, a response which is satisfied is actually higher in ranking in a sense that it is preferred. Okay. So moving on to our question, we can see for part A, it asks about the GDP of a country. It is measurable, right? So this is going to be continuous. What about part B? It says 5 possible responses to a customer satisfaction survey ranging from very satisfied to very dissatisfied. Again, this is not something you can measure. However, there are 5 possible responses. So therefore you have categories. So we can say, okay, we can the first word that comes to our head is that there are possible responses. So remember, there when you're measuring time, it's not like you can limit yourself to 5 possible responses, okay, when you're measuring height or whatever. So when we have 5 possible responses, that means we have 5 categories. So it's going to be a categorical variable, and the ranking here matters, therefore it is ordinal. Okay, the last question is a person's name. Remember, a name is not measurable. So this is a categorical variable, and there is no ranking, there is no hierarchy. So therefore this is a nominal variable. Okay, moving on to the next question. Let me show you the next question. Okay, the question says the data below contains measurements of low density lipoproteins, also known as bad cholesterol, in the blood of 30 patients. Data are measured in milligrams per deciliters. They want us to construct a histogram. As you can see, the data is already ordered, as in it's in ascending what do you call it? I can't wait a second, I have a message that I need to respond to. Okay, the data is already ordered from the lowest to the highest. So yeah, so in ascending order. However, if it is not, then I would highly recommend everybody to, before they draw a histogram, to draw a stem and leaf. And I'll show you why that is actually very beneficial. Let's just practice stem and leaf over here. The stem is going to be in the hundreds and the leaves are going to be the tens. Okay, so 0, 9, we have 95, 96, 96, 98, 99, 99. 1, 2, 3, 4, 5, 6 entries here. So, and with 100 we have 101, 101, 102, 102, 103, 104, 104, 107, 107. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 entries here. Okay, with 111 we have 111, 112, 113, 113, 114, 115, 117. So 1, 2, 3, 4, 5, 6, 7. 7 entries here. Then with 120 we have 121, 123, 124, 127, 129. So we have 5 entries here. And with 100 in the 30s we have 131, 135, so 2 entries here. And with in the 40s we have 143, so 1 entry here. So a 6 plus a 9 plus a 7 plus a 5 plus a 2 plus a 3 should give us a 30. As you can see that we can see that the data is positively skewed here. So this actually helps us to give us a idea of where the mean and mode and medium of this data will be. So the data is positively skewed. Okay, so now let's start with making the histogram. What we can see is that the lowest value, so let's just call it, in statistics we call it the lowest value, is a 95, and the highest value is a 143. So we can like just approximate this to a 90 and we can call this a 150. So it's going to be easier for us to determine the class interval and the class width. So for instance, I can say a 150 minus a 90, which is the approximate range of this data, is it's 60, right? So, and we have, we can divide how many, like, what should be the width of each. I think if we keep the width 10, then we can have 6 class intervals. So it depends. If I decide that I want the width to be a 10, because it's easy for me to like divide a 60 by a 10, right? So if I take the width as I could even take the width as a 5, right? Or maybe even 6. That is your choice. When you're doing data representation on a software such as Excel, it will decide the width and the range, everything itself. It's just a one click away. Okay, so this means that the number of intervals are going to be 60 divided by a 10 is going to be a 6. So let's start by first writing down the class intervals. Okay, so I wanted to start with a 90. So 90 is included and 100 is not included. Okay, then moving on, 100 is included and 110 is not included. Okay, then 110 and 120. As you can see, this is going to like the stem and leaf is really going to come in handy here. So actually I changed my mind. Even if the data is ordered, still make a stem and leaf in your as a rough work, because it really helps us to put the cardinality of all the elements that actually fall in this range. Okay, the next class interval is from 120. The width is 10, so it's going to end at 130. Starts from 130, ends at 140, starts at 140 and ends at 150. Okay, so this is the class interval, and the width is actually we decided on a constant width of 10. So each interval has the same width, which is 10. And now I want to write in the frequency, or basically the count of how many elements in our data set belong in this. So I'm searching for elements in that lie from 90 to 100. As you can see, this is the range. So it's going to be a 6. Then from 100 to 110, however, 110 is not included, right? So this is actually going to really help. I think the answer is going to be just 9752. Yeah, that's so in the range 100 till less than 110, we have 9 entries. From 110 to 120, we have 7, and then 5 and a 2 and a 1. So this is where a stem and leaf comes in handy. Stem and leaf comes in handy, and actually it can even help you decide how many the width depending on the amount of intervals. So for instance, if I made the stem and leaf, from the stem and leaf I can see that the optimal level of intervals is actually 6. So the stem and leaf even helps me decide the width of each class interval. Okay, so now that we've done the frequency, the next thing we want to calculate is called the relative frequency. And the relative frequency is just the frequency of each class width divided by the total total amount of entries in the data set. So this is going to be a 6 divided by, I think they were 30. Yeah, so let me calculate this. 6 actually 6 5s are, I think 6 divided by 30, so it's a 0.2. So we have a 0.2 here, and 9 divided by 30, is a 0.3, a 7 divided by 30 is a 0.233, a 5 divided by 30 is a 0.167, a 2 divided by 30 is a 0.067, and a 1 divided by 30 is a 0.033. Okay, the last thing that is called density. So the density of each class interval is the relative frequency divided by the class width. So that's basically 0.2 divided by a 10, a 0.3 divided by a 10, 0.233 divided by a 10, 0.167 divided by a 10, 0.067 divided by 10, 0.033 divided by 10, and these are very easy to calculate. You don't need a calculator. The decimal point just increases, so decreases, sorry. 0.0233, 0.0167, 0.0067, 0.0033. Okay, so now we have the whole information that is needed to make a histogram. So the next step is just to have the density. Actually, if you in Excel, when they make the when the software makes the histogram, it just keeps the frequency on the vertical axis. So one option is that you take frequency of each interval on the vertical axis, and then you keep the interval itself on the x-axis. So this is one option. This was actually used in previous S1 exams. This is what was required, but lately they want you to actually write the density of each on the vertical axis. So we are going to stick to the latest requirement, which is the density of each class interval. Okay, so since we start from a 90, I'm just going to say make this sign here to show that there are values here, and I'm going to start with a 90, then 100, 110, 120, 130, 140, and 150. On this side, we could say it's very small, right? 0.0. So let's start with a 0.005, and then let's keep a gap like this. 3, 3, 3, 3, 3, 3, 3. Okay. 0.010, 0.015, 0.020, 0.025, 0.030, 0.035. Okay, so in the first interval we have a 0.02. So a 0.02 for the first interval. Okay, this was the first interval. So we have 0.02 in the first interval. What about the second? A 0.03. Okay, the second interval is 0.03. Easy enough. The third is a 0.0233, a little bit above this one. So a little bit like almost here. Okay. The next is a 0.016. So we can guess that it's here. And then we have a 0.067, 0.067, 0.0. I'm just approximating it to be here. And the last is a 0.0. Oh, that's even below this. Okay, so this is what the histogram looks like, and we can actually again easily see that it is positively skewed. So we will expect the mean to be greater than the median, and we'll expect the median to be greater than the mode, because this is the diagram shows us, and even the stem and leaf showed us that we have a positively skewed data set. Okay, so we've done part A. Now the next part is find the mean, given that the sum of the, okay, they've given us information that the sum of the data set is this. Okay, and they want us to find the mean, the median, and the standard deviation, and they've also given us this data. Okay, so the sum of all the values is a 3, 3, 4, 2, and the sum of square of each is a 3, 7, 7, 0, 7, 6. Okay, so let's find out these. It's going to be easy enough, because we're just going to oh, I didn't copy it. Let me cut this here. You're just going to use the formulas and you'll be able to find these quite easily. So the formula for the mean of the sample is the summation of all values divided by total values. So we have a 3, 3, 4, 2 in the numerator, and the total number of values is 30. So 111.4 is the mean. And the standard deviation written as S, I'm going to write the sample variance first, is basically 1 over an n minus 1 summation. I'm just going to put a bracket here, x square minus n x bar square. Okay, so I'm going to have a 1 over a 29, and then we have a 377076 minus a 30 into a 3342 square. Okay, and then to get this the standard deviation, I need to take the under root of this expression. So we can pause the video and use a calculator to find this, and the answer is going to be a 12.38. So we found the mean and the standard deviation. What about the median? Okay, so remember we have 30 entries, so 3 plus 1 divided by 2 is a 31 over 2. So that's a 2 1s are 2, 2 5s are 10.5. So this is going to be, we need the average of the 5th and the 16th term is going to be the median. So what is the 15th term? Let's find out. Let's look at the stem and leaf for this. So we have 6 entries here, 9, so 15. This makes a total of 15. So the 15th entry is going to be 107, and the 16th entry is going to be 111. This is the 16. Okay, so the 15th entry is 107, and the 16th entry is 111. Another way you can do is just write over here. You can say 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. This is the 15th entry, 107, and therefore this is the next entry. So we have to take an average of this to find the median, which is basically the middle value. This is the 15th entry. The 16th entry is a 111. So therefore the median, which is basically the middle value, is 107 plus 111 divided by a 2. So let me take my calculator out and verify. 107 plus 111 is a 218 over a 2. So therefore it's 109. So the median in this question is 109. Okay. The last part before I end this session is comment on the data given in given the shape of the histogram. Oh, we've actually already told you guys that it is positively skewed. Therefore, the mean has to be greater than the median. So let's verify this. In part C, the mean is 111.4, and yeah, it is actually greater than the median. So yeah, that the reason being that we have positively skewed data. There is another sample examination question number 3, but since I don't want the videos to be too lengthy, I'm going to end this lecture right here, and I'll make another one for the next question. So I hope this lecture was useful, and I'll see you in the next one. Take care.